ACS Fellows interviews, Roger Clarke on 11th of February 2025. Thank you very much for joining us, Roger. So if we could kick off with how you entered the IT sector.
Thanks, Paul. Well, I started out as a cadet with CSR, then a sugar company, to do chemical engineering. After a year of that, I switched and I actually joined a financial services company as an assistant to the company secretary. And unbeknownst to me, that was my first systems work, because amongst the things we did, dealing on the short-term money market, managing treasury cash flows and so on, we also ran a debenture registry. We took secured loans from members of the public to lend to the company. We ran that in Kalamazoo binders, which were big, hulking black things with well-structured documents in them. And what that did for us was to provide us with the database. And we needed to have proper procedures, and we actually drew flowcharts for the procedures that we ran. And unbeknownst to me, there was my future already laid out for me. So I was there a couple of years, moved into accountancy from there, and I was with several companies. Dow Chemical was one of them. Angus and Robertson Book Publishers was another. I've even done royalties systems. There's an arcane corner of the world. But at that stage, I was still thinking accounting. The systems bit was just emergent and starting to understand that all these then manual systems, there were no computers running in either of those places locally in those days. I was becoming interested in the systems way of thinking. Parallel to that, I was studying at university from ChemEng through economics, accountancy, business law, business statistics, all the good things you do in a commerce degree. And I got lucky because I was in the second cohort run by a bloke called Phil Grouse, who set up the information systems and data processing courses at New South Wales in an accounting and business context. And there we, for instance, we did machine language, although it was emulated because it was a precisely 16 register, 16 machine instruction machine that he emulated. But it gave us the understanding of how you manipulate registers, how you actually do adds and subtracts and multiplies at the most basic level of a machine. We also did PL0, which was a subset of PL1, which is actually not a dead language yet, but it was used in both F111s for technical programming, and it was used in subsequent large scale, the largest system I was ever involved in at the London Stock Exchange, for commercial system. It was an extremely good, well-structured language. PL1, PL0 was a proper subset, so we were writing good, clean, structured code. We're now talking about 1970. And we could do good systems. I was trying to break into the computer industry. I'm still in accounting at that stage, and I cracked it through a company called Warmald. I had a data processing setup with a General Electric 405. You've got to get an idea of the scale of this thing. 32K 6-bit words. Try and compute that. Not 32 meg, not 32 terabytes, 32K. My first personal Apple Macintosh in April 1984 had both more memory and a way more powerful processor. It didn't have as good storage capacity because we were using the very early disks in those days on the Macintosh. We had 5 fast tape drives on this GE405. Already when I joined them, the company ran debtors and creditors and a couple of other smaller systems for about 20 different subsidiaries of Warmald. And they were all run as independent operations. States ran independently then. You didn't fly interstate. It was too slow to take the train interstate. You didn't often travel interstate. I did do jobs in Newcastle, and I once went to Brisbane for business for Warmalds. But we didn't do travel. We didn't have communications in those days like we had them progressively in the years since. So I then did inventory systems with them. I did payroll systems with them. I did a range of other systems, including some time-sharing systems of a technical nature, some simulation work. I did some work on computing the minimum area that could be served by a fire sprinkler system. It's a requirement at law that you be able to demonstrate that you've got sufficient power served through the piping design in order to actually put a fire out of a given size. You can only do it in one part of the building, but you can do that bit before the fire escapes. So I wrote that stuff in Fortran. I was mostly working in COBOL, but we did that in Fortran for obvious reasons. A formula translator was a much better way to solve problems of a technical kind, whereas COBOL was an effective way of specifying procedures, the kinds of things that you did in a debenture register, for example.
Yep.
So that was the way that I got into the industry. It had been a fight to get in there. But Canberra-based government had discovered a few years earlier that there was insufficient training, mostly no training at universities. So they set up a thing called the Programmer in Training Scheme, which taught programming, systems analysis and systems design. And that ran through the latter part of the 60s and into the 70s, and it supplied an awful lot of important people to the industry. And my boss at Warmels was one of the graduates of the BIT scheme. So that's how I got into it.
Right, yeah. And then into the more modern era, so you moved into academia and...
No, not for a while. Now, academe was 20% of my work life, slap bang in the middle, and it was an accident. No, I was in commercial software development right the way through, moving then into contracting and consulting work. The first thing I did was an interlude. I'd been working with a shipping container organisation in the CBD in Sydney, and I did another specialist kind of container inventory system. We'd call it these days an asset management system. Containers travel around the world and they come back again. So you actually have to pull them back into your own inventory, and there's all sorts of attributes of them. And by then we actually had some direct access to disks, which made it a little bit easier to write some of the systems, particularly at speed. After a couple of years there, that was a really sensible, professional, reasonably steady sort of a place. I got sucked in to a strange byway, which took me out of the IT industry per se for 18 months, but I was adjacent to it. What happened was that I'd been in one of those odd units at university, in which you did sort of projects on the side that were nothing to do with your major. UNSW was always big on that. And a bunch of blokes in my class, a chemical engineer and an architect, started waffling on about how computers were going to destroy civilization.
Right.
So I asked the lecturer in charge, Graham Pond, I can still remember him, this is 1971 to 72, and I asked him if I could write a reply next week. So I did the class next week.
Right.
And I debunked all the rubbish that they were talking about, and at the end of it there were 3 points they'd made. I said, actually, I haven't got an answer to them. And privacy was the big element.
Right.
There were several other things. We now talk about automated decision making, but back then privacy was what needed to be addressed. So I took that apart and put it back together again and discovered that, hell, there's a problem here in terms of data management and in terms of data collection and in terms of data leakage. And I've been involved in it for the 53 years since. For 18 months, I got sucked in by the New South Wales Privacy Committee, which had just been formed, and wrote for them one of the world's first ever guides for corporations and government agencies. We did it for both, on how you run personal data systems, is what I call them then. There was no word. We were writing things from scratch. And because of that, I've been involved right the way through the OECD guideline era, because I had met Michael Kirby when he was running the Law Reform Commission, and I subsequently did a lot of interaction with him during the OECD period when he was developing guidelines for the world. I got involved some years later in the establishment of the very first Privacy Act, because I'd been involved in the Australia card by then, and a Privacy Act came out of that, which we kicked into shape and ended up with at that stage, decent sort of a Privacy Act. So I've been involved in privacy ever since. So I had that interlude. I was still interacting with the industry. By this stage, 1974, I was a member of the Computer Society.
Right.
See, I didn't join it originally. Even though I've been in the industry fully since 71, I've written programs since 1967, which was just after the Computer Society was formed. I wasn't about computers, I was about systems.
Right.
And to a very considerable extent, I still am. Computers are a means to an end. I lost my train of thought there.
The systems and computers are a means to an end.
Yeah, as a means to an end. Getting to the ACS. What I did was join the fledgling Australian Institute of Systems Analysts, AISA. It ran for probably 20 years, but I was a member for 5 or 6 years there. I ran the events in Sydney for quite some years.
Yeah.
I was still very junior in the industry. Before I got a job, I think I was already running events because I wanted to learn.
Yeah.
We were doing case studies, we were getting speakers on this, that and the other, in project management, the full gamut of systems analysis work. So because I was busy there up until 74, 5, 6 with the Institute, I only joined the Computer Society in 74. But in 74, 5, the New South Wales Attorney General, John Maddison, engaged a professor of law at Sydney University to write a learned work on what should we, the state of New South Wales, do to regulate computers.
Right.
So on behalf of the New South Wales branch of the ACS, I formed a special interest group. We didn't do policy committees. We called it a special interest group because that was quick and easy.
Yeah.
And I got a small group of people together and we ran some events, we held some discussions, we made some submissions. And our purpose was to ensure that the fledgling computer industry, because it still was not going to be burdened or destroyed by inappropriate, ineffectual, overreaching regulation.
Yeah.
And look how successful I was. Because there's never been any decent regulation of the private sector in Australia, and we suffer badly from my success and subsequent failure as a lobbyist on behalf of the public interest. We are still in a mess. So yes, I was very successful on behalf of the industry, together with my colleagues back there in the early 70s. What they did was to pass an act to create a committee so that the committee could handle inquiries, handle complaints, do studies of its own accord, and had powers to investigate, but had no powers to enforce anything.
Yeah.
So everything we wrote was guidance, and I got sucked in to do the data end of that.
Yeah.
There were lots of other facets to privacy as well as data privacy. So I had that interlude.
Right.
And then I cleared off overseas for 5.5 years.
Okay. Yeah. And what did you get up to overseas?
Well, it took me a little while to get a contract as a systems analyst, and I thought I was going to have to be a COBOL programmer full time. I mean, I'd written lots of COBOL, but I asked smart questions in interviews like, well, do you want the skill in the ASASI 68 standard or the ANSI 74? And the interviewer didn't know what I was talking about. And I was like, oops, bad play, Roger. So I didn't get a job as a COBOL programmer, but I got a job as a systems analyst and designer at the London Stock Exchange.
Yeah.
A huge 150 man year. Maybe it's not huge anymore, but it was then a very big system, a batch system.
Yeah.
But it was the back end for all the overnight processing for the stock exchange. It had never been done before.
Yeah.
It was still doing manual tickets. I'd actually worked for Binet in Australia over Christmas one year, 6-8 weeks. I knew all about matching tickets. I knew enough about stock exchanges. I'd invested a bit by then. So here I was designing the front end of this system because it had been misdesigned by some O&M, organisation and methods people, who thought they knew how to design and they didn't. So here's this plane already taking off because the code was being written, the testing specs were being written, we had proper test harnesses, very professional setup, and I was having to redesign the front end in flight. And we pulled it off, and 18 months later it went live and was very successful. And the big bang in 1986, the online system, the world's first large-scale online trading system, followed on from that. My friends carried on and did that stuff. So I had a great 18 months in London, in Moorgate, just north edge of the city, doing that. From there I moved to Switzerland. I got lucky. You can't get work permits in Switzerland, but I cracked one. And worked for 3.5 years for a software house in Zurich, also in Basel and Bern, across a wide range of industries. And what that enabled me to do, which was probably one of my better claims, particularly in the technical phase of my life, was program generators.
Yep.
I'd written one when I'd been back in the shipping company, but it was for fun. It was on the side. It turned into a master's thesis, and I used COBOL to write a COBOL program generator. And it demonstrably produced much cleaner code much faster once you'd set it up. Obviously, you had to invest to get the particular template right and then work out the right way to get the parameters fed into it. And the master's thesis was more than just a program generator. It was how you do structured systems analysis, design and implementation in COBOL. Because people had said you couldn't do it. Well, you could, and we did. So in Switzerland, I got to implement that at scale across several teams, and we could generate stuff on, by that stage, went the microcomputer era. I also did it for mainframes, but we mostly did it on mini computer period.
Sure.
Jumped a generation there. So we were working on mini computers on Unix-like systems, Primos, VMS. And I was doing all of this in COBOL, but we weren't writing much COBOL. I was just writing the templates. We needed 4 or 5 templates by then for the diversity of programs we were writing, and got enormous productivity out of it. And I wrote up and published on that stuff. Then we discovered that there was, in of all places, Switzerland, a serious big program generator system, which could go across multiple operating systems. It could do both batch-based and online. It could do both mini-computer-based and mainframe-based systems, which are utterly different operating system structures and utterly different program structures. And you could write one set of parameters and generate for both. I couldn't do that. I had written macros. This was built over the top of its own macro language, so there were layers of generating going on in there. But I became a bit of a specialist in that, worked with the supplier of it, Reinhold Dorner, in a nearby village of Dubendorf. And when I eventually came back to Australia, I had a mate who had actually bought the rights to this product called Delta. So I helped him for the first year I was back in Sydney in 1982, 83, that was. So program generation, and by then we're talking 4GLs, and the interface that you were using to talk to Delta was a 4th generation language. You were specifying parameters. You were saying, choose this particular program solution, feed this into it, generate that for me. Oh, and we'll need a little bit of own code here. A little box of own code to do little corners that weren't covered by the templates. So I was assisting him selling that and supporting that around the country. So I had a nice migration back into the Australian market. We're talking now 1982-3. And then it got a bit silly because I was also doing a half-time senior lectureship at UNSW in information systems. Cyril Brooks, the professor there, had arrived when I was finishing my first degree. I did my master's with him, and would have moved on and done a PhD with him, except I went overseas instead. Just in spare time. I mean, I was never a part-time person at universities. But I was doing this half-time senior lectureship for him, writing case studies on brilliant data model that the UNSW library had done, one of the world's largest. It took, the wall was about that and that combined. It was a huge wall fall for the complete data model for a library, university library. And they made a huge amount of money as soon as they moved out into the private sector with their methods. So I did a case study on that. I taught COBOL to second and third year students on the fly. It was easy stuff. And then I got wind of the fact that there was a readership in information systems going at the Australian National University. And I said, here I am in the inner western suburbs, on a busy street. I'd managed to buy into Sydney somehow. Had no capital coming back from Europe. We'd been travelling. But I got into the housing market. I got the second kid just arrived, thinking, it's a bit busy around here. It's a bit busy than it used to be. Sydney was a lot of fun when we were young. Both my wife and I had been in Sydney as singles. But it's not quite as much fun. It's going to take us how long to get to Haberfield, to get to Beecroft, somewhere nice to live for the family to be? I wonder what Canberra's like. So I took this readership. I followed Ron Webber, into the job. He'd moved to University of Queensland, another fellow of the ACS, of course, and he'd also been in accounting and in information systems. He was dual, like I'm dual, and or differently. Ron and I are a bit different, but we've both got that double several bits to our bows. And it took me 11 and a half years to realise that I'd managed to do 5.5 years worth of work because you're swimming in treacle.
Right.
Even then you were swimming in treacle in universities. It's way worse now. Now the professional staff run the university, and the people on point actually doing things with students just down in the slums.
Right.
Professors don't run universities anymore. So it's much, much worse. I wouldn't want to be involved in it. Well, I am as a visiting professor in 2 different universities, but I wouldn't want to be involved full-time in universities. It was an interesting period in terms of what we needed to teach, assimilate and teach. And of course, I and my colleagues kept up consultancy because you couldn't stay alive and understand what was going on unless we were sufficiently involved in the industry. So I never left the industry, but we had to take the first students to use computers in universities. We had to get the first laboratory set up. We of course used Macintoshes. And we had to teach them all manner of things. Unfortunately, in the first stage of skills like keyboards, teaching them effective use of spreadsheet models, which emerged during this time, during the time I was there. They were sensible things to do, but we had to do an awful lot of drudgery in order to build the infrastructure that students needed and build the teaching materials. There were no textbooks for this kind of thing. And work out, well, we're supposed to be teaching ANU students here. We're not supposed to be teaching tech courses. So we've got to have a level of insight into this and layers of understanding and education, not just training. So it was a bit challenging. It was good fun. It was just too damn slow, and the politics was so time wasting. Yes, there was another anecdote I was going to tell you about there. Back in '74, when I'd done some contracting work, as one did in those days, one of the jobs I'd done was to write a net present value calculation tool for a mate who was a financial planner at Reckitt and Coleman. Subsequently ran Reckitt and Coleman Asia. He was a flyer, like all my mates were. And this was written in COBOL because that's what they had on their Honeywell 2000 from memory in their head office in North Sydney. And what he wanted to do was to be able to just feed in all the numbers that you feed in when you've got a net present value calculation to evaluate a project proposal. And just put them in as parameters. And have it spit out the analysis, and then he could fiddle it some more and do what ifs.
Make the numbers work.
So I did all that in COBOL. Now, it's not the best language to write that in. I mean, you use Fortran to be better in many respects, particularly structured Fortran. There's all sorts of languages to be better than COBOL, but COBOL's what they had. COBOL's what I knew. I had templates. I'd written program generators. So I did all this, including string handling, which COBOL didn't really support. This was in '74. In 1978, when VisiCalc was announced, and made squillions for the producer of it, I sat there and I thought, I wrote one of those. Well, not quite generalised as much, but I'd laid out the virtual matrix inside a memory that was so small that you couldn't actually put the matrix in memory. I'd done all that, and I got to generalise that. Slightly slowly because it's COBOL and you can't generalise quite that quickly with COBOL, but I could have stood back and said, wait a minute, how do I write a general one of those? And then I could have said, microcomputers are the coming thing, you know, why don't I try this on an Altair or a Commodore or something? This is because it wasn't until Apple II that there was a workable device that this could actually be written on and implemented on, but I didn't think of this. And it was only 4 years earlier, and I'd already done it. But Dan Bricklin made the money and became famous, and I didn't make the money or become famous.
So VisiCalc being the first spreadsheet, commercial spreadsheet.
And funnily enough, in '83 at UNSW, we were teaching master's students and then MBA students, and then the city had to use VisiCalc on Apple IIs. It was one of the things that Cyril Brooks was organising with the city. He was closely tied to what we now call CIOs all the way around. He ran the CIOs club in Sydney. So in they came, and in they sent their senior staff to work out what this VisiCalc was all about. Yeah. So I tripped over to get again there, tearing my hair out, thinking this should be my software.
Right.
Too late. So here I am then in 1983, teaching students how to use, by then, Multiplan, ultimately Excel, because Microsoft bought Excel. That's why it's such a good product.
Yeah.
And they haven't buggered it up. So, so we were doing things like that for years. And I did lots and lots of consulting on the side, and subsequently walked out of the ANU and went back to consultancy.
Right.
So, and by then I'd gone through the 4GLs phase. I'd moved into organisational exploitation of information technology. We were talking about IT alignment, getting IT to be not just data processing, but to actually do strategic stuff to, generate sensible management reports, but also enable managers to do the what-ifs, to play around with decision support systems, group decision support systems, and so forth. I'd already supervised group decision support systems, PhDs. So we were into a different frame, a different realm, and I haven't seriously coded, PHP maybe, but I haven't really coded since 1983.
Right.
17 years, but a long time ago.
Yeah.
Because I won't say you don't need to code to be an ACS member anymore, because there's an argument that there's got to be some core there, otherwise you won't understand what's under the bonnet.
Sure.
But you don't need to be a specialist coder. You don't need to be terribly good at it.
Yeah.
You need to understand what it's about, what the constraints are, what the possibilities are. Different world. And I'd moved through those phases by then.
Yeah. So on that, how did you pick up into ACS?
Well, it had been around a lot, and of course I tripped over ACS members a bit, and increasingly there were people I knew who were ACS members, and they ran events that I didn't run.
Right.
We didn't tend to have the big end of town when it came to demonstration site visits, talks about the new architectures that were coming in. I got some good ones. I remember TUI's installed the first ICL 2903, which had a particularly interesting machine architecture and was very usable for systems analysts and programmers, commercial programmers. But no, ACS had better links at the top end of town. If not into boardrooms, they were certainly into what we now call CIO level.
Yeah.
So it was natural that I moved into that. Big numbers in those days. It was a big monthly meeting. There were special interest groups that did lots of things. So there were multiple meetings a month. The staff at that stage of the ACS was 0.
Right.
Orman Brown, an ex-branch chair of New South Wales branch, when he retired, cobbled a bit of money together. There was a bit of money, I wouldn't say sloshing around, but there was a bit of money there. So he set up an office and ran a New South Wales branch office for some years, and gradually took on membership for the whole of the country, and gradually took on bits of the policy work for the country. And by that stage he'd grown to a massive, I think, 3 staff.
Right.
So worlds apart now. We didn't have revenue lines then like we have now. We had membership, and membership funding was quite significant, and it enabled us to achieve a few things, but far less so. The moral of that story is all events were totally being run by members. Didn't happen if members didn't run it. So special interest groups were critical.
Yes.
You had to subset and get energy from lots of people. We harnessed energy from so many people to run so many events. We were less hidebound with insurance and legals and IP ownership and all those things that tie organisations in knots these days. So we got a lot done, got a lot of meetings done.
Yeah.
And did a lot of policy work.
Yeah.
So I suppose that brings us to 1985. In 1985, in March, a bloke whose name I've forgotten now, it's in all my articles, had a word in Bob Hawke's ear and said, it'd be a really good idea for taxpayers if you'd set up an Australia card.
Right, yeah.
And Hawkey said, "What's that about then?" And so this bloke peddled his wares, and for the next 2.5 years we wasted our time trying to explain to them what a really seriously bad idea this was.
Yeah.
And I did a huge amount of work in there, most of the media work. Probably 2/3 of the media work I've done in my life. I've done quite a bit of media work. Was done during that era. Funding up with ministers and explaining to the minister how he'd got it wrong. John Brumby, I remember, subsequently Victorian Premier, but then he was trying to lead caucus.
Right.
And he and I sat nose to nose in the ABC studios down the road here, debating things, and me saying to him, no, that's not what the bill says, Minister. He wasn't a minister. Mr. Brumby, have a look at Clause 33, will you?
Yeah.
Read those words to me.
Yeah.
It was a mess, that period.
It was a fraught time, yeah.
One of the major vehicles I used, I did a lot of this as myself as an academic. It always said redoing information systems on the screen, but I did some of it as an ACS committee chair, I remember. Yes, I was already chair. I was chair of the Economic, Legal and Social Implications Committee, so I did it as the committee chair at national level for the ACS, in close harmony with Ashley Goldsworthy, who'd been successively, well, he was my predecessor, chair of this committee.
Yeah.
He'd been president already, he was president again, he was chair of this, that and the other. He ran international conferences, he then ran IFIP. So I did all of this in close association with Ashley, because I needed somebody to check me. Because I could have been saying intemperate things, or my analysis could have led me to say things that were very harsh on the government. And to some extent I did say those things, but Ashley kept me in line and made sure that I was saying things in the way that a computer society should say these things. So I learned a bit about rephrasing my first drafts back in that era. Ultimately, we didn't beat it. There were about 5 of us who were really seriously active in this. Another one, a fellow of the ACS as well, Graham Greenleaf, man who established Austley in his spare time. Graham and I were two of the major players. But what beat it was 2 things. One was its own impossibility. The design did not work, the justifications did not work, and we demonstrated all of that. And gradually that was becoming clearer to people. The media had come to understand those bits, and they'd come to understand all the bits about why, even if it worked, it'd be a terribly, terribly bad idea for society. And the public got out in the street. Apart from the Vietnam moratorium, and depending on how you measure it, the anti-apartheid demonstrations. The Australia Card demonstrations around the country were the biggest thing. They're the big three in the history of Australia. Eureka Stockade, was a very limited little area. But it might have been more significant politically, but these 3 things were the big ones. So, but that was 2.5 years of I didn't do much else with my spare time. So it was all a bit. Fraud's not the word. It was just hard work trying to get through to these people. And of course, we're now in a situation where, just to leap ahead a little bit, one of my beefs about where we stand with the Computer Society at the moment is that LSIC disappeared. The Economic, Legal and Social Implications Committee existed from 1973 when Ashley founded it, had it for 10 or 12 years. I then took it over for 10. And luminaries, people much more powerful than me, subsequently chaired it as well. So at least 3 other presidents have chaired it prior to becoming president of the ACS. And it's never been big numbers of people, but it said a lot of important things. And it said them from a social impact perspective. We never forget that we're the people who peddle computing and technologies and systems. We never forget the benefits that our systems can do, but we had to face up, even then, to the damage that could be done if we didn't do this well. Or if we headed it off in a particular direction and made these priorities instead of these priorities. So we were always doing that. Now where do we stand? Well, the power, just in compute terms, has done that. But the power in scope, if you like, has done that too. We've now got enormous capacity to do ill that we didn't have back then when I was chairing that committee. And we don't have an LSIC. It disappeared. So what do we do when we do policy? we do industry policy. We say, well, we've got members and they need jobs, and we have PPP partners who are employers, and they want sensible technology to shine through and not to be held back unduly and all that sort of stuff. We do that. Where's the social responsibility side of it? Where is the bit that says, take AI as an example, there is no, I'll make the statement here, there is no worthwhile AI regulation anywhere, and that includes Europe. The US emphatically is not going to have it in the next 4 years. Australia is emphatically not going to have it in the next 4 years either. There's frameworks and there's guidance and there's voluntary this and voluntary that. And I've done the publications, I've done the analyses of all of these things. And they don't scratch the surface. They score about 25 to 30% and they're not enforceable.
Right.
So what we should be saying is AI has got some real prospects in some areas, and it is horrendously wrong in an awful lot of ways in terms of the results it gives. What are we doing to teach people, A, to understand that, B, to work out what the difference is, C, to build in the caution they need and the controls they need, the safeguards, in order to use AI properly? And we're not doing that. It's all right to have an AI ethics committee, but the AI ethics committee isn't getting any traction. We've got to be out there beating drums. If it's good enough for Bill Gates, if it's good enough for Elon Musk not that long ago, despite the fact he's got shares in AI, both of them have said it's the end of the world. If we don't do this properly, we're stuffed. There's been successive people. Stephen Hawking said it. Bill Wozniak said it. They're the four I use on my slides. I've got lots more people saying it. So we have a responsibility to do that too. So to me, one of the disappointments I've got with the industry as a whole and with ACS in its current mode is that we don't have that arm anymore.
Right.
We've undermined our own code of ethics because our code of ethics used to say as point number one, essentially, do good.
Right.
Essentially as number two, do no harm. No, those weren't the words. Because it was written in late 20th century bureaucraties is the way they were written. I was part of the formation of code of ethics over the years, so it's my fault too. But they were writ large right at the beginning. They were 1 and 2. After that, we then worried about all those other things about be polite to one another. Don't write down other professionals. Be careful in your speech. All good things. But that's not what the world's about. The world is not going to be undermined by me insulting another member of the ACS. It is going to be brought to its knees if we, as developers, develop the wrong kinds of things the wrong way and they break. And they are targeted at, for instance, human rights people in Thailand, say, or in the Middle East, which is exactly what a lot of the IT is aimed at. So I'm disappointed that we aren't doing that, and I wish I was spending more time working us as the ACS back towards doing more of that kind of thing. I'm not saying stop the industry economics. It's totally within our scope to do that. But we're bigger than that. So that's a bit of a fast forward.
That's an interesting segue into the second or third part, if you like, of this interview. Is where do you see the future going? We are, as you were alluding to, right now as we're recording this, we seem to be at a very big juncture with the technology sector.
We've got a major problem because apart from that irresponsibility, I called it in my writings, and that by irresponsibility I don't mean that you and I are being irresponsible. I do, but what I really mean is that the structures build irresponsibility in. They don't build responsibility in. If you look at the value chain for generative AI, which is the area I'm obviously working on at the moment, because getting safeguards and controls on that is absolutely vital. So my current papers are out in that area. If we look at this, it's a more or less a supply chain, a little bit of a supply network, but let's keep it simple and think of it as a chain. So there's 5 or 6 different layers here. There's the inventors. Inventors invent. They wouldn't know what a bloody ethic was if it bit them. They don't know what it's going to do. They don't know what effects it's going to have. It's not their job to. If they become innovators as well, as some inventors do, then they start having a responsibility. Hang on a tick. let's just think, there's different ways I could design this or apply this brilliant idea I've got. Some of them might not work out real well. So as an innovator, you should surely have some, at least ethical responsibilities. How about some legal ones?
Okay.
And on we go. And the way we've got it structured, nobody's got any responsibility.
Yeah.
In the 1980s, one of the submissions I did to Parliament was on software liability, it was called then. The proposition was that we should have liabilities as an industry, and I've been director of companies that this would have applied to.
Yeah.
Well, I'm a director of my own, so I'd be subject to it. We have responsibilities to our clients and arguably to the public in relation to safety, in relation to reliability, robustness, resilience, all those sorts of things. Now, the bar's got to be reasonably high because it's not that easy to do it really, really, really well. You can never test everything.
Yeah.
It's mathematically impossible to do so. But you've got to have some responsibilities for building in quality early, middle, ongoing, and subsequently.
Yeah.
And we have no responsibilities to do that. So I argued back then that product liability, including strict liabilities where the thing's inherently dangerous, motor mower, and if the blade flies off and hits somebody in the head, it's strict liability. It's not a question of negligence. You're liable for that. That's why you've got public liability insurance. So there's circumstances in which strict liability is needed. Safety critical systems, of which we have a very strong national special interest group, is an area where strict liability, handled carefully, you've got to write these laws very carefully, strict liability needs to apply. So I think control rooms in especially nuclear power stations, but think about the dangerous areas. Traffic control systems, air traffic control. You don't need strict liability for most of the software we write, but you need responsibility built in. And we don't have any. So that's one of our major problems. Linked with that is the quality thing. And I did some notes the other day because I've been wanting to write for years my view on where quality has come and gone in the 55 years I've been in the industry. We were aware how important quality was when I started. Simply because the bloody program wouldn't work if you hadn't done quality work up front. And we very quickly came to the realisation that even if the program worked, the system wouldn't, or the system would not do the thing that you'd originally asked it to do. And there were some pretty obvious quality things that you had to do from the beginning, but we never built up the insights that engineering has built up over the years. Now, engineering is bolstered. You can't build a bridge without standards, without liabilities. And they don't. The laws all in civilised countries all impose both standards and certification and liabilities. And we've never generated that expectation of ourselves. We call it software engineering, but it's not quite engineering in the sense in which civil and mining engineering are properly controlled. So we improved quality. We started moving quality assurance back earlier in the system. And to me, the peak that we reached was 1990, give or take. It was a thing called structured systems analysis and design. And structured coding was a given by then, and there's another story there. Now, at that point, we were able to teach in universities. I was still in universities in 1990. We had the textbooks. They were there, Ed Jordan's, Constantine's. You could pick these things up and you could show them to students, and you could show how, with 3 dimensions of design, you could do assurance. It was built into the fabric of how you went about things. So structured code walkthroughs were done. Sorry, that's at that stage. But structured walkthroughs of analysis of requirement statements are tenable. The structured is a little bit different from the structure down here because obviously you've got more open-ended things. You're using human language up here, whereas you're using tighter specified languages down here. We had all of that laid out, and we taught that stuff. And at that point, some smart consultants, James Martin popularised it and was well known for it, but others did some as well, came up with what they called rapid application development. And rapid application development, at its best, has an idea to it, and that idea is we have built by 1990 a lot of bureaucracy in here. You draw the charts and the critical path method charts that we did draw for how we're going to weave our way through this to get to the end and get it done in time to meet the deadline. We did that kind of stuff in project management in practice, but there's an awful lot of strands, and we're not very good at managing critical paths, of estimating what the lengths of the different arrows are and what the risks are on some of those arrows, because it's a risk-based thing as well. Let's cut to the chase and let's pick a few here and ask ourselves why we can't shorten that one, why we can't skip that one, why we can't be 2/3 of the way through this one before this one, which is nominally a task dependency, before that one's finished. Because we already know what it's going to deliver. Surely we can cut things short. Now, the best bits of rapid application development as it was originally conceived made sense. And we could do it. And you can show my PhD was going to be on project management using Petri nets. And it's still a doable PhD, amazingly. And it has sufficient flexibility. You can design for this sort of thing in a network diagram. RAD became understood as shortcut everything.
Right. Okay. Yeah.
We very rapidly got to it being radical rather than rapid application development, to being QAD, quick and dirty, rather than rapid application development. People excuse themselves, all sorts of appalling behaviours as professionals, because the boss wants it fast. He wants it fast, and he understands that it might, in the end, cost more, but only if we're unlucky. He's not fussed about good, because he's going to have moved on in his job, so will you. You're a contractor anyway, what are you worried about? It's all about fast. And quality fell away. And it's stayed fallen away, and it's become embedded in the culture. We no longer see quality as being a beginning to end activity. We've got quality associations that exist, which are disjunct from computer systems analysis, data management communities. And that is appalling. We have safety critical systems, but there are vast numbers of systems that badly need some of what they do. Not all of it, because that's huge bureaucracy to make sure you're doing it right. But in that in-between zone, where you want to risk manage things, we must have much more culture of quality than we've got. Now, map to that the question of the increase in power. Map to that the fact that we are now moving into automated inferencing using completely opaque mechanisms, purely empirical is what I call AI/ML. If you're using neural nets, you have no rationale. The answer cannot be explained rationally. It happens that way. It's how the numbers work out. That's all you can say.
It's a black box.
It's a black box. So we have inferencing being done that we cannot explain. And once again, if we had liabilities to appear in court and explain why we made that decision, how we drew that inference, why you didn't offer that loan. Oh, the credit score came out at 5 points below the threshold you're on. Yes. How did that happen? What were the key factors in it coming out lower? In the old days, you could go back. Because it was an algorithm, and you could say, well, the heavier weightings are on these, and the score on those two was too low. You could do it. You can't do it anymore. It's an empirical heap. So that's the start, the inferencing. Then comes the decision making. We're now doing automated decision making. Okay, self-advertisement, once again, the case study of Robodebt, myself and some colleagues published a little while ago, and it explains chapter and verse about how that was done and the mistakes that were made. Now, a lot of it had become published. The Royal Commissioner missed a few things, but by and large, the Royal Commissioner got a lot of it out. A lot of it was out by then anyway. But nobody at all ever noticed one absolutely critical thing, including the Royal Commissioner and the other commentators. There is almost no mention of any IT, ACS, systems, information systems, data management person anywhere in the documentation. The documentation is, well, it's deeper than that because the Royal Commission came along. There is no mention. I've studied it all. Now, how can that be? Let me tell you the two anecdotes that I'm aware of an IT person actually being involved. A contractor at a critical point said, no, you can't release that latest change because the change package that's been agreed and the testing protocols to do that are here.
Yeah.
And we're only up to 1/3 of the way through it.
Right.
That was 11 a.m. At 2:30 he was frog marched out the door.
Right.
And the second element that did turn up in this whole history of robo-debt that involves an IT person was that person's boss had to give evidence in front of, now I can't remember whether it was the Senate Committee or the Royal Commissioner, and gave the evidence as to what had occurred there, and played a completely straight bat.
Yeah.
As an EL2, I think he was. So top end of the management spectrum in Canberra terms for those who aren't Canberra devotees.
Yep.
He just played a straight bat, said it as it was.
Yeah.
Years later, he's not in the ACS, and as an EL2.
That's the next step up.
It's the next step up.
Yep.
I've never tracked him down, but he did not appear to prosper.
No, I can imagine. Right.
Courageous, and all he was doing was playing a dead straight bat and passing no value judgments and providing the information to, it must have been the Royal Commissioner. Those are the two instances of anybody anybody with the capabilities being involved in robo-debt. Now, that's an enormous problem with the executives in the public service.
Yeah.
But it's also a problem with and I'm a big part of this, I'm on the management committee of the ACS, it's a problem that we have never solved. We have never managed to get our standing so high. We should be in a position where any DepSec should be quavering in his boots about the very idea that an IT collapse could occur and no IT person had their fingerprints all over it.
Yeah.
Where were the reviews? Where were the assurances that the DepSec responsible for IT gave to the other DepSecs that this was not going to implode? We should have them quivering in their boots, and we don't.
Yeah.
And that's my fault and other people's faults who've been on MC and Congress and have tried over the years. We've never got there.
Yeah.
So there's the quality aspect, the irresponsibility aspects to me are the things that I do worry about. I'm enthused by some bits of generative AI, as is everybody else, but I've done a huge amount of skeptical testing over the years. And each of the skeptical tests that I've applied, it only takes 2 steps, and you've blown the poor generative AI out of the water. Do not dig too deeply, and therefore do not rely too heavily.
On that. Yeah.
Real world checking is something we're very bad at. It's expensive.
Yeah.
So go back to old fashioned systems. Actually going out there and checking whether the people who you refused credit to were the people you should have refused credit to. It's a really difficult thing to get out in the field and do that. So you don't do much of it. We do all our testing internally. So it's self-referential. We don't pick up the real world errors. Now with generative AI, all of us are running our own systems. We're all producing these documents. Well, I'm not. Lots of people are being told to now generate documents because generative AI writes better than you do, mate. Tell it what you want, get it to tidy it up, will you? And nobody says, and then check whether there's anything that you said there that may have misled the misled the tool into saying something that other people are going to misunderstand.
Right.
Which bits have come out wrongly. And we don't have that step in there, and that's actually quite a hard step. What was the claim I read in the paper this morning? One of the agencies is justified buying Copilot license on the basis that it only needs to save 13 minutes per employee per, long period of time in order to pay for itself. To which my question then is, did that person reinvest that 13 minutes in checking the outputs and whether they corresponded with reality, whether they corresponded with what I meant to say, not what I said? Remember the Ada Lovelace dictum? You know that one?
No.
The first programmer. 1820s. It was the difference engine. It wasn't called the computer in those days. And Ada Lovelace says, and I paraphrase, because she used... what period? Georgian English, very old expression she used. But basically she said, computers do not do what you want them to do, computers do what you tell them to do.
Right,
Well, now think generative AI and think about the casual especially the one that you do at 2:30 in the afternoon after a beer, rather than the one that you do at 10:30 when you're still okay. And I've just had my second coffee of the day. I'm working at my best. Not then, it's the bad one. Think of how many misphrasings. Ooh, I shouldn't have said it quite like that, should I? How many of those we do in a day? How many of those have I done in this interview? It's a given. It's human.
Yeah, absolutely.
So where's the 13 minutes spent on checking the correspondence? And we don't have it built in. So those things do really perturb me, the power without the responsibility.
So where do you see ACS's role? You've alluded to where you'd like to see it. Where do you see it?
Well, we've got to do a couple of things. The highly desirable thing is that we rebuild our social responsibility component without losing the other things that we do and do decently. So that's don't call it the Economic, Legal and Social Implications Committee. For starters, the word environmental, I don't have to go in there. We've got to get back to that, and we've got to imbue that right the way through. So all policy committees are thinking along those lines as well. But the other huge challenge that I tussle with as an ancient old fogey who cannot speak modern language is how do we reach, both in language and in values, the people who are coming into our industry. The motivation for people in the mid-60s through to certainly the mid-80s, 90s in joining the ACS was, on average, across everybody, probably 40% altruism. For some people, a very heavy dose of altruism. The word altruism doesn't even get used much anymore. That's how out of date I am. The intention to do something for the other bloke, the intention to give back something to the industry that I'm benefiting from, and I quite enjoy the work I do. Those kinds of feelings were very strong, and a quite small percentage of people, I knew few over the years, were in there just for themselves, period. What do we hear now? When we try to get younger volunteers, and one looks at the age pattern of BECs, I don't know that we've ever captured that data, but if you look at the age profile of branch executive committees, we get older and older. It's the same with all volunteer organisations. All of the other people I talk to, my wife's run the biggest dog club in Canberra for years, and the age profile there, it's quite fearsome. The number of people over 70 who are holding volunteer organisations together is fearsome. Now the ACS isn't quite in those straits yet, but the age profile has shifted up, and the younger people coming in are all so convinced that they're oh so busy. As we always have been in the industry, we're busy people. But they see themselves as being oh so busy. I've got these children, I've got to do all the runs to school. I've got to be a proper family man as well as a worker, which wasn't quite as heavy on us in my day. It's harder now, agreed. Blokes have actually got to pull their weight more than us blokes used to. Happy with that, but it's all too hard. They won't do it. And the younger people who come in are looking for what the society can do for me. It's all about value propositions, and it's all about marketing value propositions, and that is so foreign to the notion of a professional society to people like me. How do we meet the new age? How do we deal with successive generations? There's different values across each of the generations. We've all done the XYZ millennial, I call it the I generation, little I. We've all noted the difference in value sets and expectations and work-life balance. How do we do this across those generations and yet attract sufficiently large proportions of the industry? We don't need everybody in the industry in the ACS. We couldn't cope. But we need a decent bloody percentage, and we haven't got it. How do we encourage those people? How do we sell those people, not just on this is what we've got for you, look how cheap this is for that entry fee and that annual membership fee. It's got to be more than that. If you're only in it for the access that you get to events, for the access you get to networks, for the mentoring schemes you get, if you're only in it for that, that's not what professional society is meant to be about. We've got to do better. So those are two things that I do concern me for the future. It's really challenging, and I say that as a member of the committees that is supposed to be trying to do this with and for the ACS.
So, final thoughts, because we've gone well over time.
Oh,
Reflecting on a career in technology, what's your advice to somebody coming into it?
Well, have fun, but increase your responsibility in what you're doing. I mean, hell, I rode motorcycles when I was young. It's all relative. You start out being much more laissez-faire and much more wild and experimental. But the more power you accrue to yourself by virtue of the studies you do, the experience you gain with technologies, with people, with the combination into socio-technical systems to make the whole damn thing work and deliver, the more power you get, the more careful you've got to be with that power. I didn't have anybody quite say that to me at the beginning. I had to learn my way into that. Now, I learned my way into that because, why did I learn my way into that? It was partly some of the people I worked with. It was certainly the Institute for Systems Analysts and then the people in the ACS. It was just part of, it was imbued in, it was just part of the deal. One of the things I say is my company, of course, wants to be a member of industry associations, and I want to drive industry economic arguments and non-stupid regulation, only enough regulation, parsimonious regulation, less red tape, more effectiveness. I want to do all of that in industry associations. Another part of me wants to be in a professional society, which has got different priorities and can pursue different value sets. And I'm hoping that there are ways and means whereby we can imbue more of that in the other generations, and I'm bugging if I know how we do it because we haven't found it yet.
Well, on that note, wind up on that. I really appreciate your time today, Roger.
Thanks,
and very much a wide-ranging conversation. Thank you very much for that.
Thanks, Paul.